Hello, I am Sabini Kumar. Today I am going to explain about the MOSFET current equation, basic MOSFET current equation. So, normally, if you already know what will be the charge Q is equals to okay I into T, means what will be the current total charge in per unit time. If this is the frame and per unit time how much charge go from there to there, that will be the current. Okay, then if we want to find the current, then what we have to find? First, total charge in per unit second. Then if I assume the charge density is the QD, coulomb per meter, and one more thing, we have to assume the velocity of charge, means drift velocity, will be meter per second. Then what will be the total charge? Q total will be QD into VD. How? See, this much charge, coulomb per meter, this will be charge in the 1 meter, and this will be the velocity of that charge. Then that much charge, this much charge will go from this frame to other frame. Means this in the 1 meter frame, that much charge will go. So means that much current is appear at the moment. So now what will be the current? So this will be the this is the total, no, sorry, this will be the current. Okay, how? Means because that much charge will go from there to there, means that much, this will be nothing but a current, because in per unit second this much charge will go from this frame to this, here to here, means in this frame. Okay, so this will be the current. So for the current, now we want our charge per unit meter, means coulomb per unit, total charge per meter, and the velocity of the charge. So how we will find the charge unit? So we will see if this is the gate terminal, and this is our metal, and after that this is oxide, because MOSFET is nothing but a metal oxide semiconductor. Okay, then this will be the semiconductor. This is semiconductor. Let us suppose this is N type MOSFET. Then what will the body? This is P type. Then you know, if this is my atom, then in the atom some electron is there. So if I apply some force from outside, this is for example positive voltage, then this electron will go from this this is from its own position to the free position, means this will be it will free from the atom. So when it will free from the atom, then this atom will automatically create one positive, means this atom will positively charge, and this is not movable, because then if it is electron is free, then this is movable, but this will be not movable charge. Okay, so when you apply the positive charge at the gate terminal, VGS, let us suppose source and drain is grounded. I assumed you know the basics of MOSFET. So when this is source and gate is grounded, then you apply VGS greater than 0, then what will happen? As here, because this is the P type, then whole the P type atoms is there, and from if you apply the positive charge, then what will happen? It will repel, and it will just repel the hole, and electron go towards this region, and what will happen? Some positive and a negative not movable charge will created here, means if hole will repel, then what will happen? Negative charge will created here, but this negative is nothing but not movable charge. And what will happen then, this will for the let us suppose after VGS the electric field is how much, so that the electron will now what will happen, if negative charge will created there here, then uh, near about this electron will repel also, this that will repel. And after some voltage, let us suppose VTH, after that much voltage, what will happen, this electron is able to move in this depletion region, because the force is very high now. Okay, so this voltage is called effective voltage, because after the VTH voltage at the gate, the electron will come to the channel. Let us suppose this is a channel. Then after the VTH voltage, how much voltage you apply at the gate and source, means how much voltage difference you apply, positive voltage difference you applied at the gate source terminal. Because of that, how many charge is created on this metal plate, that will directly repel here also in the channel region. Means this electron, means movable charge, will just mirror in this region. So this will be the effective voltage for the creation of movable charge in the channel region. Okay, means effective voltage will be VGS minus VT. This is effective voltage for the movable charge creation in the channel region. Okay, that will take part into the current generation when you apply the voltage difference. Okay, and where you apply, if this is the gate and this is the source and this is drain, let us suppose source is grounded, then at the drain just you apply the positive voltage, let us suppose VD, and then what will happen, for example, when VD was 0, then here some electron is there, this is movable charge now. But when you apply the VD, then what will happen, it will look like this. Why? Because of this voltage, this electron, the voltage difference, for example here this is VGS minus VTH. Now here what will be the voltage difference, here this is VGS minus VTH minus VD means less voltage is there, positive, means here less movable charge, less number of movable charge should be there, because voltage is less here, and here voltage is how much, VGS minus VT. Suppose I taken this area Vx, so in this region this is x at the x length, and this let us suppose here the drain, the effective voltage, because of drain positive voltage, the effective voltage, what effective voltage is here, if you see, then it will be VGS minus VTH minus Vx. Because of this, just suppose, because of this voltage here, what you observe, see, from 0 to VD if you go, and just suppose this is VD is equal to VGS minus VT, then what will happen, from here to here, what will happen, this voltage gone to 0, voltage difference, because here voltage difference here is what, VGS minus VT, and if you go from here to here, then it will reduce, because of this drain voltage, and if you apply equal to this voltage, then it will go to 0, then there will be, at this point there will be no charge. Okay, so the effective voltage, and because of this, if you see, then here to here some voltage difference will created, and because of this voltage difference, the electron will flow, and because of the flowing of electron, current will generate. Okay, so now let us suppose I apply VD voltage, and because of that effective voltage at this region, at the x distance from the source, Vx, then what will be the total, what will be the effective voltage for the at in the x region, at the x distance from the 0 volt, it will be VGS minus VTH minus Vx. Okay, so now the current will be QD into VGS minus VTH minus Vx. And one more thing, if you apply positive voltage to the gate, and that electron will appear here, so between these two plates one capacitance will build up. This capacitance is COX. This is capacitance per unit area. Okay, means if I multiply with the W, then this will become capacitance per unit length. Okay, then charge, if you see, then charge Q is equals to C into V. Okay, this is the voltage, this is voltage, then C is equals to, you know what, VD is nothing but VD is nothing but, okay, here I thought I make a mistake. This is the effective voltage, and after that, you know, VD is equals to mu into E, and from there VD is equals to E is equals to dV by dx, you know, from the basics of this is electric field, and this is the you know, electric field is equals to dV by dx. From there I write, okay, and now VD will be mu n dV by dx upon dx. Okay, now from there, if you, and I already told you Q is equals to C into V, and this is the voltage. Okay, effective voltage for the I how much effective charge is there. So effective charge will happen because of the effective voltage, then effective voltage will be VGS minus VTH minus Vx. This will be the charge per unit per unit area, and if I multiply with W, then what will be the unit of this charge per unit length. Okay, means this is charge per unit length. So now what at that time what I want, this charge per unit length and the drift velocity. So drift velocity is this, and the charge per unit total charge is this. So just I multiply and I will the current. Now just multiply. I is equals to QD is what, COX W VGS minus VTS minus Vx, and VD is what, mu n dVx by dx, and I calculated from x distance. So here what will be the voltage from 0 to, let us suppose L is the channel length, then from 0 to L you have to integrate it. So from 0 to L, I is equals to COX W VGS minus VTH minus Vx mu n and dVx by, okay, now voltage will go from 0 to VDS, and here this distance is go from 0 to L and x. Just integrate and you will find the current what I told you already. This is mu n COX WIL VGS minus VTH into VDS VDS square by 2. You will get this. Okay, thank you all. Thank you. Okay, this.